Okay, gentlemen. So today we are going to start chapter number 4. Chapter number 4 about planning, project planning and scheduling, or about you can say construction planning and scheduling. So today we are going to discuss chapter 4 is about a critical path method. This chapter is there are a lot many things like constraints and other things. So we will discuss this chapter in two parts. So today we will cover, inshallah, how to find the critical path for the activities. So allow me to say, Bismillah, alhamdulillah, wassalatu wassalamu ala rasulullah. Rabbi shrah li sadri wa yassir li amri wa hlul uqdatan min lisani yafqahu qawli. Assalamu alaikum wa rahmatullah to each one of you. So today the topic is chapter number 4 is about a critical path method. So we will determine the critical path of the activities. Inshallah, let's go. We will let me make it. So chapter 4 about a critical path method, construction planning and scheduling, or some people say this course is construction planning. So let's see as a critical path method. Okay, critical path method, a scheduling technique using networks for graphic display of the work plan. Okay. So in this we are using a graphic display network scheduling technique to find the critical path. So network calculation determine when activities can be performed, the expected completion date of the project. So we will find the project completion time of the project and the critical path of the project. So what are the activities on the critical path that we must complete on time to complete the project according to our contract? If we delay any activity on the critical path, so then our project will get delayed. So to avoid any delay, we have to complete all those activities on the critical path according to the time that we have calculated in the critical path. So here is a simple they are going to give example that is a hunting trip example is that you are going for, say for example, for fishing on a canal or sea. So what you need is you are preparing for yourself to what you need to use that for hunting gear. So maybe you get the food or you get the hunting gear that you use for hunting, and then you get your jeep ready and go for hunting. So you see now some activities will start early or they will be float. So all these things we are not clear, but when we put them in the network schedule, so we will get the critical path. We get the critical path, then we will know what activity we should start first, and we should follow the critical path. So let to prepare a project schedule. So there are steps to schedule a project. So there are like 4 steps. They are like compulsory to understand, prepare the schedule. And there are 4 steps. So there are supplementary steps, additional steps. So we will discuss both. Let's see, is to prepare a schedule, we need to break down the project into activities. Okay, so project, so we should have break down our project into activities. Say for example, like the foundation is one activity. Okay, construction of file cap or the so then construction of the column is another activity. Okay, cross head. Or whatever, if we are doing a building work, so say for example, it's brickwork is one activity, plastering is another activity. Okay, so fixing doors is another activity. Okay, so making beams, casting beams or casting slab. So these are like examples of activities. So we have to break down the project into activities, and then we need to decide the duration of each activity. Okay, how much time is required to do that work. Then we will determine the logic relationship, which activity should be done first and then next. Okay. So we have to determine the relationship between them, so that this activity should complete for first, or this we can start parallel, so this area we will determine the logic. Then we draw the network diagram and then perform the CPM calculations. So CPM calculations mean we will find early start, early finish, late start, late finish, okay, total float and free float, and then we draw the critical path in the network schedule. Then supplementary steps, we will see or review and analyze the schedule and implementation of the schedule. Actually, all these points, 4+4 points, we are going to discuss in detail. Okay, so let's see here. Just let me cover quickly. Then number 3 is supplementary step is monitor and control, and number 4 is database revision and feedback. Okay. So with this, let's move with the first step is break down the project into activities. Okay, break down the project into activities, steps to schedule a project. Okay. So first reason, we have to break down the project into activities. So reasonable activity size. Okay. So sometimes we have, contract restrictions. Okay. So build this project on a fast track base. But we have to keep the activity simple that we can understand, when it's going to start and going to finish. So sometimes we have a simple versus a complex activities. Okay, so sometimes activities are simple and sometimes they are complex. So we have to break down those complex activities into smaller activities that we can understand how much it's going, when it's going to start and when it's going to finish. So some people name activities as task also. Okay, task is just the other name for activities. Then we should have a work breakdown structure. This we have talked before. So then see, when we make a schedule, first we decide the work breakdown structure. Okay, like this is these are the civil works, these are the electrical works, these are the mechanical works, these are the like finishing work or associated works. So under this work breakdown structure, we can see what are the activities under each work breakdown structure. So then we will get the summary and all those activities that how much time they are going to take for this WPS. So there could be coding of activities. Okay, so computer understand that this each activity is a code. And then with that, with the reference, we put the other this activity in a relationship. So it's we can put in the computer what is the activity description. In short, we put A, B, C, D, but in detail we can put the description in the Primavera software. So then activities types. Okay, so we should know there are what are the activity types, what are the name of those tasks, whether it's a milestone task, so when it's going to start and when it's going to finish. So milestones are these are important points in the network schedule, that we want to achieve this milestone until this time. Okay, so how much level of effort is required to complete those activities. Okay, so activities could be like piling work in other activity, and foundation is another activity. Okay, construction of column, construction of beam. So it's sometimes a design also. Okay, what kind of a design we are talking is, whether it's a substructure design or superstructure design. So we can decide the activities, project into activities that we can understand easily. So we will be inshallah discussing these like factors to be considered in defining activities. So this is like nature of work is important. What is homogeneity? If two different materials then divide into two activities. Okay, so like if there are two different materials, two rates are there, so then we should divide that work into two activities. So location, floor or segment, whether activities occurring at different locations must be separated. So we will assign separate, like activity on, like brickwork on the first floor or brickwork on the second floor. So we should name differently. So whatever the sections or segments, so wherever the location, so we should have each activity separate, okay, with respect to their different locations. Then size and their duration. Divide large activities into smaller. Okay, so that we can understand when how much time this activity is taking. So this we have to decide. We will, go more in detail step by step. So to avoid, that we can finish on time, not consume a lot of time. So I need to keep the things straight. So number 4 is timing. So chronology sequence of events. So it's a portion of work may be delayed. Okay, like there is a storage area, say for example. So we should keep these activities separately. So when this will be built, so it's a sequence of those events. So we should keep those activities separately. If we want to make a delay in some area, so we should keep separate those activities. Then a responsibility, okay, break down the work done by different parties. So if there are subcontractors, this part is done by another subcontractor and this part is done by another subcontractor. So we should separate those activities also. Then it's a phase division made by the designers. So sometimes we have phases of construction, like this is a design phase, this is a construction phase, this is the commissioning phase of the project. So from the designer, we should keep separate each activity in each phase. Then there are sometimes contractual restrictions follow start or finish time from the that is given from the owner side. So usually we keep the start time, and then we follow prepare the schedule and see if it's how it's going to match with the finish time. So this is a level of confidence in the duration. Divide the activities into smaller to increase confidence level. So if you see, for example, if the foundation, we don't know how much it will take, so we can divide the foundation into more detail, like how much time for fixing the formwork, fixing the reinforcement, then fixing the formwork, how much time for casting of concrete. So this, we can split those activities in more detail, so that we should put the duration with our confidence, that duration is representing actual duration. So this, like there are, we discuss some factors that we are helpful in deciding the number of activities for our project. So how we split our project into activities. So let's see, it's never combine two activities if they are measured differently. Okay, if their measurement different, or is the way of measurement is different, or their price is different. So then, or if they are performed at different locations, so we will keep those activities separately. At one location this activity, another location other name. Performed during different times of period. Okay, so if activities are performed at different time period, one is like after 5 days, another is after maybe 1 month. So we should keep those activities separately, are performed by different crews. Okay, so if activities are performed by different crew members, so groups, so we should keep them also separate, name them separately. The title of each activity must indicate the work type. Title of each activity must indicate the work type, what, and the location. Okay, so what is the activity and where is the location of this activity. Okay, so this is like from the name of the activity, we should be able to understand, as a planning engineer, you need to be careful about these things. Then how to define activities. Are you confident enough in the duration? So if not, break it down. So this is like a general principle. If we don't understand, we should break our activities. Okay, and especially for the duration, we should involve the management also, like the site people. Not only the planning engineer should decide the time by himself. No, he should involve the construction manager or the project manager or the site engineers, so to decide the duration of those activities. No, definition of activity. Okay, definition. A basic unit of work as part of the total project that is easily measured and controlled. Okay, so like activity is a work that we can understand, you know, when it starts, when it's going to finish, okay, and we can control it. It is also called task. Okay, some people call activities as a task. It is time and resource consuming. So every activity will be time and resource consuming. Resource mean it will need, we need to spend money to finish that, complete that activity, or we need materials, we need labor force, okay, we need construction machinery or equipment to carry out that work. Okay, so every activity is time and resource consuming. Unit of measure. Okay, so we need to decide, you know, what are the unit of measure. So if there is a complex like a formwork, we can measure in meter square. Okay, a rebar we can measure in kilogram or ton. Concrete we can measure in meter cube, okay, or yard cube. So finish then finish that work. Okay, foundation. See how 4 activities like you know, we can decide how much time is required. You know, so we can divide those activities. Okay, for fixing a formwork, fixing of the reinforcement or rebars, casting of concrete, doing the finishing work, and then maybe taking out that formwork or stripping that formwork. So see, we discuss definition of the activity. So let's move next is events and milestones. Okay, an event, a point in time that is usually the start or finish of a certain activity. Okay, so an event is like what is the a start point or the finish point of the activity. So we call it event. You know. So important events are called sometimes milestone. Okay, milestone we put in the schedule like a start milestone such as NTP, network time protocol. And finish milestone such as a substantial completion. When will be the substantial completion of the project? Okay, this will be like a milestone. Okay. Or we can put like in a multi-story building, like we will complete the ground floor up to this point and the first floor up to this point, and for third floor up to this, you know, this month. So we can put like a milestone this way also. An activity has a start date and a finish date. Okay, so activity like this activity will start on this date and it will take maybe 10 days time and it will finish on this date. Okay, so every activity has a start point and end point. An event or milestone has a start date or a finish date. So event is just because there is a duration is usually 0 for the events. So it's they could have maybe just the start point or the end point of that event. Like we will complete this much work or first floor up to this point. Okay, after 1 month or after 2 months, whatever, you know, we decide. So then it make easy that we will try to achieve those events, you know, that up to this point we can finish the design for the foundation. Okay, so events and milestone. Let's move next. So here, see, we will make a work breakdown structure where we told you that we will make a work breakdown structure. So here they are putting like different levels of WBS. So there is a building, and then in the building, like building, there is a foundation work, there is a wall construction, there is exterior and interior finishes, there is mechanical work, there is a site work. So now just take the building works, we divide this into construction of column or the wall construction. So there is the slabs, there is the beams, there is the stairs. And now we, so it's the second level. So if we go down just from the like building walls, we separated into building construction into column and walls and slabs and beams and stairs. So now we have just let's see the slabs. So we can see what kind of slabs are there at third level. So there is a post tension slab, there is a flat slab, there is a waffle slab, there is a one-way slab, or there is a two-way slab. So we can divide the slab in this way. And if we take just a post tension slab, so what is involved in that one at level 4? So how much how much is false work, okay? Or how much the fixing of a reinforcement for that post tension slab, and how much like if there is a tendons or those cables are post tension tendons. So then costing of concrete for that post tension slab. Okay. So now we take a false work. So we can see like there is a maybe scaffolding involved. There is the shores. There is the so these kind of soffit and edges form work. So we can divide it for up to 5 levels. So this is like how we go down to make more and understand more detail of some particular thing, to understand that how we can fix the time for each activity. So we should know how to break down the work at the lower levels. Okay. With this WBS, like work breakdown structure, we can say it's a design. We can divide design into substructure design or superstructure design, or if there is a small bridge construction, so we can say it's a piling work or pile cap or foundation work, and then column and then superstructure. Okay, superstructure. So for the bridge, maybe box girders or eye girders, including the deck slab and median barrier or the parapet, lighting, filling, marking, surfacing. So all these things will be part of the superstructure. Then let's see the step 2. So we move steps to schedule of a project. Step 2 is estimate activity duration. Okay, estimate activity duration. Okay, so it means we have to decide the time. Okay, so usually decide the time in number of days, but we can also put for using the schedule of hours or week or month. Okay. So when we put a day, so when your primary schedule, if you contract or expand, so you can see that in months also, or the weeks, you can see the days. Okay, duration, total quantity. Okay, let's see the quantity expression divided by the productivity. Okay, so if we have a total quantity of expression is 10,000 meter cube, and productivity rate of the crew in one day is 800 meter cube per day. So we divide by 800, so it means we need 12.5 days, or around of 13 days time is required. So this is the way we can decide the duration. Okay, so productivity rate for all kinds of works are available online on the website. There are websites from Construction Industry Institute or Construction Specific Institute. So we can see those productivity rates are available. So we can use those to decide quantities are given in the BOQ. So we can decide the duration this way. Okay, but duration also dependent if we are working like with multiple crews, one duration for one crew is this much. If we are working two crews, so labor force is more, or if we working in one shift, like 8 hours per day, or we working in two shift, or we working around the clock, 24 hours a day. So then duration will be reduced. So this is like how we calculate the duration of activity. So we can also make a productivity adjustment with factors. Like if conditions are worse, so it will take more time to finish that activity. So then the productivity factor will be, we will multiply with the factor will be more than 1. But if conditions are better, then productive factor will be less than 1. So usually for average conditions, productivity rates are given, so it's 1. Okay. So we decide the estimate the duration of the activity. Now let's see the again some more so we have to decide the calendar. Okay, calendar is very important for to decide that we will work during these 5 days are the working days. So it means Friday, like Friday and Saturday will be holiday, or in US is maybe Saturday and Sunday will be holiday. So we have to decide the calendar. Okay. During the year, like there is some Eid holidays or Eid al-Adha or Eid al-Fitr or maybe some Yom al-Watni. So what are the national holidays in each country? So we can set the calendar according to that. The student should never unilaterally assign duration to activities without consultation with and getting approval from the project manager and the technical team. Okay, so it means the scheduler or the planning engineer, so he should be deciding the duration with the help of the site team, like the project construction manager or the project manager, so that he should not take responsibility, because the site construction team, construction manager, project manager, so site engineers, they know that how much time is required or what are the difficulties in actually building the and carrying out those or executing those activities. Okay. So involve them in deciding the duration. So it's deciding duration should be a teamwork, not like individual work. You can discuss with the side people. Okay, number three is third step, like determine logical relationship. Okay, determine logical relationship. So we have to establish the logical relationship, like what will be the generally relationship we use finish to start, that this activity will finish, then next will start. Okay, so if there is a lag given, like this next activity will start with 4 days lag, it means after completion of activity A, there will be 4 days lag, and then activity B will start. Okay, so we can have like external relationship. Have you included activities to be performed by external parties? Okay, so like what work is being executed by subcontractors. So then include their time for their work. Okay. So logic, sometimes we call it hard versus soft logic. Hard versus resource in soft logic. Hard logic cannot be relaxed. Okay? Soft logic can be relaxed if more resources are required. So we can, if we, soft logic means we can increase the resources. Okay, increase the resources, then we can reduce the duration. Okay. So if, say, for example, we are working with 2 people, we can have like 4 people. So we are increasing the resources. Okay. Imposed constraints. Okay, this there will be sometime constraints from the government side, like from the owner, that stop the work or start this work on this date. So there is sometimes utilities underneath, when you, like in India, there is a subway project. So when they were building stations, so they found that there is a water supply line, or there is a telephone cable line, or there is so the electric company, there is a power line underneath, so that need to be relocated. Okay, so in that case, we have to follow those imposed constraints, from the owner side, from the client. So we will discuss scheduling with constraints, inshallah. So let's move forward with the, so it's important is here that we should determine the logical relationship between activities. Okay, how this, what after this activity, what will be the next activity we will build. So draw network. So after now we have decided the activities, their duration and their logic. Now we'll draw the network diagram. Okay, and then perform the CPM calculations. So subcontractor schedule must be compatible with the master schedule. Okay, work of the subcontractors that should follow the work of the prime contractor. Imposed finish date for subcontractors. Sometime that prime contractor, they can put some dates, imposed finish date, that the subcontractor should complete this work until this time. So we have to decide, like in the network schedule, what are the non-work days? Okay, if there is any holidays coming or national holidays, so or the weekend, we have to put those work days as a non-work day. So check software default rules, check setting. So in the software, we will check the setting, what kind of type of is your software is set. What sometimes we have interruptible activities or not, or we will be just using the continuous activities. Make sure any specific requirement is met. Okay, so in the network schedule, whatever the specific requirement is given, so that should be met. So we will draw the network schedule and then find the CPM calculations. So do not worry, there will be a lot of examples we are going to discuss, and then things will be very clear to you, inshallah. So let's move forward with this. So what has additional steps? We discussed 4 steps. Then now we are going to see the additional steps. Number 1 is review and analyze the schedule. Some people they call it step number 5. But additional step we are going to put numbering separately. So there are 4 compulsory steps that we have discussed before, and then now 4 are additional steps. Okay. So first one additional step is review and analyze the schedule. Okay. Check logic. Back and forth. Okay. So this is very important to check the logic that a second set of professional eye is always a good idea. Wrong relationship, missing relationship. So see all your schedule. If there is any wrong relationship or illogical, or there is a relationship is missing between activities, so we have to review our schedule. Okay. So make sure there is no errors or loops or omissions. Okay, so schedule like the network diagram will follow from left to right. Okay, so it's not like a loop. It should be moving forward. So there should not be anything missing, omissions. Like there is a duration is not assigned to activity, or there is the relationship is not assigned. So we have to like this activity is just in the space. It's not only the starting activity. Like there is no predecessor, but all other activities should have predecessor. Okay. So similarly, the last activity will be the last activity, so that will have a predecessor but no successor. Okay. Check with the leaders of team involved with the project. Okay, so to review. So you are expert people from the project who have interest in scheduling. So they should also review and analyze and give comments on the schedule. So with this, let's move forward. Second additional step, like implementation of the schedule. So now we are going to we have prepared the schedule. So we are going to implement that schedule, taking the schedule from paper to action. Okay, on site. So this is the most serious step in the process. It is selling the schedule to all the parties. Okay, so now you are giving the schedule to all the parties, maybe subcontractors, the prime contractors, your project manager, your project management team, site people, construction manager. So you need to define the roles and the responsibilities. So management should have commitment, So it means when you prepare this schedule, they should be involved, So not like when you present them that they will make, think this is not logical. Okay, so their input should be in the beginning before you prepare the schedule for implementation. Okay. So let's see the next step, implementation. Continue with the step, print different reports for different parties. Okay, sometimes we print a different report for the different parties, like this part of the schedule is for this subcontract, this part of the schedule is for this subcontractors. Okay, final form is going to be your baseline schedule. So when you finalize the schedule according to the bill of quantities, like the contract, original contract that you have signed with the owner, so that schedule will be called the baseline schedule. Now, based on this baseline schedule, everything will be considered, like if there is any changes or delays or whatever happen. So this will be like every later revision of the schedule will be compared with the baseline schedule. This is more than just a decoration to the wall of the site. Okay, so schedule, it should be like represent reality that you are going to complete the project according to this one, and it's not just a decoration to the wall, because when you have schedule, when you put on the wall, they look very nice, so but they should reflect the reality, of your work. Okay, then so next step is that the third step in the additional steps is monitor and control. Okay, so monitor, define the update procedure. Okay, define the update procedure. Choose a uniform time interval for periodic updating. Like you have to update the schedule after 3 months or something. Compare the baseline with what actually has been done. Okay, so compare it always with the baseline. And then monitoring includes, like, monitoring means you are observing, reporting and analyzing. Okay, monitoring include these things that you are observing or reporting or analyzing. But when it comes to control, adds taking corrective action. So under the control, you have to bring the schedule on track. Whatever is behind schedule, so increase some resources, try to complete it on time. So then make control of the schedule. Okay, like otherwise your project will get delayed. Okay, so communicate your schedule to all the parties. Okay, and then report and make documentation. So make a printing a report for different parties, and make a record if something is delayed, for what happened, what was the reason. Implement any change. Okay, so what changes they were there, so implement any change. Okay, so this is like that you have to monitor and control the schedule. So last part is like database revision and feedback. So scheduling process is continuous and iterative. Okay, it's always iterative process. Revision, we are going to, planning engineer is working on daily basis, until the project will finish. So he will be updating the things, according to what is happening on the site. Okay, so take what is the project or activity notes. So what happened to some activities, document work stoppages with justification why the work has been stopped, what was the reason on site, is there any underground utilities like electrical line or the water supply line or telephone line. So what was the reason for stopping that work? You finished 3 jobs in the past. After finishing this job, your database has now 4 jobs. Okay. Like primary schedule is a database schedule. So because planning engineer, when they work for 3 jobs, now you have completed this job, 4 jobs. It means with you are already having experience of 4 jobs. Okay. So this will be like serve you good learning for the next projects. So this database will help you in the making schedule for the next project. Okay, so we can archive those previous schedule, and we can take help to understand things. What was the learning from the previous schedule, and we can get what we got the feedback from the site people, from the construction manager. So, and then we should keep the accessibility and confidentiality, of the schedule. So, like, because we use this for a claim settlement schedule. Will be used for claim settlement or making proof. So you have to be like the planning engineer, keep the confidentiality for the cost related items and for the any whether it's a cost or for your whatever the database, so don't disclose to on people, so you have to maintain the act ethically, so don't do any unethical things. Okay, now the new topic, budgeting and resource lab. Okay, So budgeting and resource level, like optional steps when scheduling a project. So we are going to make not only time but a cost loading. Okay, assign cost to each activity. Okay, we can assign cost to each activity. Like resource loading, we can assign or allocate the resources. Say for example, there is a activity. So we have like 12 days. And then what are the resources, like we work 8 hours per day. Okay, and then there is a operator for the equipment. He will charge $45 per hour, and there is a laborer. They will be charging $32 per hour. So then like for 8 hours, how much will be for these for the operator and for the laborer? And then there is an excavator. We are using a equipment excavator like a backhoe or something. So excavator rate is $980 per day. Okay, so total cost for this is $19,152. Okay, so we can assign these this way resource loading to the activities. So that we can also do the resource leveling, like maintain the uniform daily use of labor. So this is like a good project manager. They always keep do the resource leveling, and they don't do like kick off the labor force today and next day and different number of people and different number of people each day. So we don't do like kick out the people and like re-employ them again. So we try to maintain the resource leveling those people that we are working with us, for as long as we need them, for the project. Assigning resources versus assigning budget. Okay, sometimes why assigning resources is better than assigning budget. Okay, so if we assign those resources, just like you have seen before, that how much material cost, how much equipment cost, how much cost for the labor, so that will give you like you can update, wherever is change. Okay, but sometimes if there is a work from the subcontractor side, we can just assign the total budget, like this part of the work from subcontractor is this much the price. Okay, ease of changing, updating of the cost of an activity. Okay, so when we assign resources, it will give ease and up where have what we have to update in that activity. So it's if we assign resources, the ability to integrate with the accounting and procurement. Okay, so it will so we will have integrate with the accounting and the procurement, and then ability to estimate and store, okay, in database. So in like what we, if we have assigned those resources, productivities, man hours, and to do cost analysis. So this will help in doing the cost analysis. Ability to do resource leveling and to set upper limit on resource consumption. Okay, so that if we have assigned resources, we can do the resource level. Ability to use a resource driven activity. So what are the resource driven activities? So this will also help. So except for the subcontract work. Okay, but for the subcontractor work, we don't assign resources. We can assign the budget. Okay, so this let's move forward. Project activities. Okay, scheduler may want to include all the project related activities, whether it's a design or design review, then construction and owners activities. So owner give like a review of something or approval. So vendors, if they are supplying some equipment. Other agencies activities, like for government, we are doing testing, so that this work should be, we have to get license from the government, permit testing. So these so let's see the we are going to see the CPM calculations now. Example one. So this is we have the list activities A, B, C, D, E, F, G. Okay, and duration for each activity is given. Activity A needs 5 days, B needs 8 days, C needs 6 days. Duration for D is 9 days. Duration for E is 6 days, and there is a 3 days duration for activity F, and G will take just 1 day to complete. Then IP immediately preceding activities are given. So A is the nothing is immediately preceding activity. So means A is the starting activity. B, C will be after A, so D will be after B, and E will be after B and C, and then F will be after C, and G will be after D, E, and F. So we have seen that before, that we can draw the network diagram based on this. So C, B, C activities are after A, E is after B and C, and D is after B, F is after C, and then activity G is after D, E, F. Okay, so we have the duration. So we got the diagram, node diagram. Okay. So then we can do the forward pass. Okay, so it's 0 is the like starting time for A, 0 duration 5 is 5. So go to B is from A, 5 will go to B plus 8 days is 13. Then coming to C is a 5, from A is a 5 plus 6 is 11. Then for both B and C will complete, then E will start. Okay, so this is B is completing on day 13, and this is on 11. So we will take the maximum. B 13 will come here. Take the maximum from these B and C, and then 13 plus 6 is 19. So then for D, 13 will come here, plus 9 is 22. And then 11 comes here, 11 plus 3 is 14. So now for G is D is completing on 22, E is 19, F is 14. So we'll take the maximum that all 3 activities finish, then G will start. Okay, so it means so if D is going to complete on date 22, so the starting time for G will be 22 plus 1 is 23. So this what we have done is we call it forward pass, okay, to find the early start date and early finish date of all the activities in the network diagram. We call it forward pass, okay. So now we do the backward pass. Like we start with the end activity. So 23 is the duration of the project. That this project will take 23 days to finish, okay. So 23 minus 1 is 22. So 22 will come here, minus 3 is 19. And then for D, 22 will come here. For E, minus 6 is 16. So 22 will come for D, 22 minus 9 is 13. Okay. So now with B, we have to see successor activities are D and E. Okay. So this is starting on 13 and 16. So we'll take the minimum, so that if D has to start late start 13, so B must finish at 13. So 13 minus 8 is 5, and then from this E and F, so these are the 2 successor activities for C. One is late start is 16, another is 19. So we take the minimum, 16 comes here, minus 6 is 10. So then 5 and 10 we take 5. 5 minus 5 is 0. Okay, so we have calculated the late start time and late finish time of all the activities in the network diagram. Now we can find the total float. So there we have the total float like 0 minus 0 here, and 5 minus 5, and 13 minus 13, 22 minus 22. So 0 total float gives us that we can have this critical path. And but for the other activities, we can find the total float like here 10 minus 5 is 5, 16 minus 3, 13 is 3. For activity F is 19 minus 11 is 8. So this is the total float for the other activities. Okay. So with this, we have completed this CPM calculation for this. Okay, and if we move in the table, so this in the table that. So in the table, we can list those total float, and we can also list the free float also. So we can make a table for activities A, B, C, D, E, F, G, duration, early start time, and early finish time, late start time, and late finish time from the network diagram. And then we can also list total float. Okay, total float here. So we have listed in the total float that for the critical activities, total float is 0. Okay. So let's move now we know that those activities in the previous diagram, like activities A, B, D, G, they are critical activities. Okay. So we will talk a little bit more about the critical path. A critical path, the longest continuous path in a network from start to finish. It represents the summation of the duration of activities and lags along that path, taking in consideration calendars, constraints, resources, and other impacting factors. Okay. So the constraints and these things we will discuss later, but it's the longest path. It is the shortest way to get the project done. Okay, critical path. For every network, there must be at least one critical path, but there might be more than one critical path. So in the network diagram, there will be at least one critical path from start to finish, but for complicated diagram, there could be more critical path. Okay, or it's possible that all activities are on the critical path. Multiple paths may share one or more activities. Okay, so multiple paths could be there, and they will share. Maybe one activity will be common if, or separate. So activities on the critical path by definition have no float, unless in some cases if impose finish date. Okay, critical activities then are those with the least float. Okay, so we call it least float. Actually, sometimes we call it that critical activities have a total float is 0. Okay. A critical activity, an activity on the critical path, it is an activity that is, if delayed, the entire project will get delayed. So it means if we want to finish the project on time, we have to finish all those activities on the critical path on time. No? If we delay an activity, our project will get delayed. Okay. So forward pass means that we have find the early start time and early finish time of all the activities in the network diagram. Like the process of going from the start to finish of a network in order to calculate early start and early finish dates for each activity, and the expected finish date for the entire project. So with this forward pass, we can find the project duration. Then there is the backward pass, means we are going to find the late start time and late finish time of all the activities in the network diagram. So definition is the process from the finish to start of a network in order to calculate the late start and late finish date for each activity in the network diagram. So both passes identify the critical path and a flow times for the activities. Okay, so once we have done the forward pass and backward pass, then we can find the total flow. Okay. So predecessor activity, just simple definition, previous activity, an activity that has to finish or start in order for the succeeding activities to start or finish. Okay. So these are the, we can say these are the predecessor activities and successor activities. Okay. So successor activity, an activity that cannot start until a predecessor activity has finished. Okay. Until a predecessor activity has finished. Okay. So this is like we are going to, sometimes we call a previous activity and next activity. Sometimes we call it a predecessor successor. Okay. Previous activity, next activity, or predecessor activity, successor activity. So early start denoted by ES, early start date of the early start date. The activity can start within project constraints. Okay. Early finish denoted by EF, early start date. The activity can finish within project constraints. Late start LS latest date of the activity. Latest means late date of the activity can start without delaying the completion of the project. Okay. So late finish LF latest date the activity can finish without delaying the completion of the project. Okay. Without delaying the completion of the project. So these are just small definition. Total float. Okay. So total float, the maximum amount of time an activity can be delayed from its early start date without delaying the project entire project. Okay. So total float is like we have a late start minus early start, or we can have a late finish minus early finish. Okay. Or we can have a late finish minus early start minus duration. So we will get the same value for total float. So usually total float for the critical activities is 0. Okay. So all the way, if we will get the same value if we are not dealing with the interruptible activities. We will discuss those things later, inshallah. Float is one of the most important, interesting, and controversial issue in construction, technically and legally. Okay, so float is usually the owner of the float is the contractor, but sometimes owner or a consultant want to use it, and they have to sit together and decide, who is the owner of the float. Total float is broken down into free float, independent float, and interfering float. Okay, so we can break down this float into that this is a free float, or this is the independent float, or this is the interfering float. Okay. Furthermore, if activities are allowed to be interruptible, there will be different types of restricted floats. Okay. So these things actually we will discuss later, in the next chapter. So let's see the second example is we have the activities, we have the duration, and we have the IPA immediately preceding activities list. Like activity A, duration is 5, so IP is nothing. B is 7 days duration after A, C is 4 day duration after A, D is 5 days duration after B, and E will be after B and C, F will be after C, and G will be after D and E, and H will be after E, and I will be after E and F, and J will be after G, H, and I. Okay, so there is we have like J activity is the last activity, and after 3 activities are the predecessor for it. So we draw the diagram. It's like a note diagram. So A is the starting activity, B, C are after A, then B is after B, E is after B and C, and F is after C, G is after D and E, and H is after E, and I is after E and F, and J is after G, H, and I. So we have this activity. We can find the forward pass to find early start and early finish date. Okay, so 0, 5. 5 will come here, plus 7 is 12. Then 12 comes here, plus 5 is 17. Then for E is 12 comes here. From this side, C is like 5 plus 4 is 9. So now for E is this, B is 12 and C is 9. Okay, so we take the maximum 12 here, plus 6 is 18. So for E is 18. And now for G is E is going to finish on day 18. D is on 17. So we will take the maximum for G 18 plus 8 is 26. And H is 18 will come here, plus 5 is 23. Then is E and F both finish, then I will start. Okay, so here we have 12 and 18. So 12 comes here, the higher number, plus 4 is 22. Now we have 26, 23, and 22. So the highest number 26 will come here, plus 127. Okay. So we find the early start date and early finish date, and then we find the early start and early finish. Now we start with the late start and late finish. So late finish 27 will comes here, minus 1 is 26, 26 comes here, minus 4 is 22. For E is 26 comes here, minus 5 is 21. For D is 26 comes here. So we are doing the backward pass. Okay, so 26 minus 8 is 18. Okay, so 18 comes here for D, minus 5 is 13. Okay, now for E is 3 successor activities, 18, 21, and 22. Okay, so we take the minimum. If this has the late start for G is 18, so it means E should finish on 18. Okay, so when we come back, we take the lowest. So here is 18 minus 6 is 12. Okay, so 22 comes here, minus 3 is 19. Then for C is like E is here 12 and 19. So 12, my minimum comes here. For C, minus 4 is 8. Okay. So similarly for the B is 2 activities, D and E. Okay, 13 and 12. So minus minimum 12 comes here. Because if E has to late start is 12, so B must finish at late start on late finish 12. So minimum will comes here 12, minus 7 is 5. So here we have 8 and 5. So 5 comes here, minus 5 is 0. Okay. So we find the late start, late finish date of all the activities in the network diagram. We have done the backward pass. Okay. Now we find the like a critical path where the total float is 0. This 0 minus 0 is 0, 5 minus 5 is 0, 12 minus 12 is 0, 18 minus 18 is 0, 26 minus 26 is 0. So this is our critical path, red color. Okay. Now we will find the, for the other activities, we can find the total float. Like for C is total float is 8 minus 5 is 3. For F is 19 minus 9 is 10. For H is 21 minus 18 is 3. For this activity I is 22 minus 18 is 4. And similarly for D is 13 minus 12 is 1. Okay. So we find the total float. Similarly, we can find the free float. A free float like 5 minus 5 will be, for this one, it will be 0. Okay. So there, we can discuss later. Okay, free float. Okay, free float, they are giving the definition for free float. The maximum time of the maximum amount of time an activity can be delayed without delaying the early start of the succeeding activity. So free float is total float have linked with the project duration, but free float is linked between two activities. Okay. So free float is linked between two activities. Okay, say for example, here they are putting the example that free float of activity I is the minimum of early start of the next activity I plus 1, means a next activity minus early finish of activity I. Okay, so it means free float for B, if we have to calculate, so we have to see what are the following activity or next successor activities. So successor is E and F. Okay, so we have to take minimum from, we have to see what is E is here early start is 8, for F is early start is 12. So we have to take minimum. Okay, minimum from 8 and 12, then this 8 minus this 8. Okay, so this, so we take minimum 8, then this 8 minus this 8 is 0. Okay, free float is 0. So free float is always less than or equal to the total float. Okay, free float, it's a link between two activities. Okay, now if we have this activities, find the free float for activities CFI. So for C is we have to see, here is 12, here is 9. Okay, so 9 minus 9 is 0. Okay, then F is here. So for F, we have to see what is the successor activity. 18 minus 12 is 18 minus 12 is 6. Okay, 6 will be the free float for F. And for I is like, what is the next activity for I is 26 minus 22. Okay, so that will be 4 will be the free float for activity I. Okay, so this is like how we calculate the free float, and we can list a free float for all the activities. Like for D is, it is a free float is also 1, and for F is 6, and for as you know activity H is it comes 3, and for activity I we will find it is a 4. Okay, it is 4, so we can list in the table. Okay, so guys, with this we have finished this critical path. Like we have find the critical path. So we in this we are going to find the whole critical path of the network diagram. So we find the total float and free float also. Okay, so free float, total float will give us the time that we can delay for the number of days without delaying the project duration. Free float is the time that that give us the time that we can delay that activity without affecting the starting time of the next activity, with starting time of the successor activity. So free float is that time. If we delay activity, like the float is, the free float is 0, and it means we cannot delay that activity if we want to start the successor activity on time. So this is with this we have covered this critical path method. Inshallah, we will second part we will cover more advanced things like constraints and other complicated things for related to the critical path in the next lecture in part 2. Okay, so there are about 80 slides. So I have covered 38 slides, 39 in this one. So inshallah, rest of the slides will be covered in the second part. with this, we are going to stop here. And at the end, allow me to say, Subhanak Allahumma wa bihamdika, ashhadu an la ilaha illa anta, nastaghfiruka wa natubu ilayk. Thank you very much for your attention, and inshallah, talk to you next time with the next lecture, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh.